Hi everyone. In this video, we are basically going to discuss about how to identify the terminals of nmos and pmos, because this is very important and good question. Like, if I give you nmos and a pmos, then how you are going to identify which is drain, which is source, which is gate. So this is nmos, okay, and this is pmos, okay. So this is nmos and this is pmos. So my question is, identify drain, source and gate terminal. I would request you to pause the video and just try on your own. Just think about it. Okay, so I hope you are thinking. So basically, undoubtedly, you will say this is gate. Okay, this is gate of PMOS, this is gate of NMOS. Now, which is source and which is drain? We cannot simply say which one would be. For this, we required the potentials. Okay, what potentials we are applying. So for this NMOS, let's apply the potential and then check how it is behaving. Okay, so I have applied a VDD here, over here, and a ground in the lower part. Okay, I have applied the ground in the lower part. Now what will happen? There must be some current which should flow, and it should flow from higher potential to lower potential. So let's say this is the current in nmos. Okay, so id comma n, it is the current in the nmos. Similarly, we will see for pmos also, but let's finish the discussion on nmos. So what will happen? We want to identify which is drain and which is source. So this is the main question: which is drain and which is source. Now let's, for this clarity, we should understand the construction basically. Okay, so we all know like how nmos is constructed. So we basically choose p type over here. We choose p type substrate, and two anvil are there. I hope it is clear. So two anvil are there here, n plus, here also n plus. So this is basically my nmos. Now one is source, so suppose this is my source, and one is drain, this is my drain. Okay, what happens? So in nmos, majority charge carrier is electron. So why we term source means it will contain majority charge carriers. It will contain majority charge carriers, and drain will drain it. Drain will drain these charges. So now my question is, we already know this is electron. So what is happening? Source is providing the electrons to whom? To drain. Okay, so source is providing the electrons to drain. So electrons is moving from source to drain. Okay, from source to drain. Then what would be the direction of current? Okay, what would be the direction of current, which we termed as id of n? So the direction of the current will be drain to source. Okay, so drain to source will be the direction of my current. Now if I came over here, so drain to source is my direction of current, so this must be drain and this must be source. Okay, this must be drain and this must be source. I hope you got my point. Okay, so simply we have go to the structure of this nmos and we see what is actually happening. So source is providing the electrons and drain is basically draining it. So electron direction from source to drain, so current direction would be drain to source. And now since we have applied our potential over here, which is upper one is the VDD and the lower one is the ground, so my current direction is VDD to ground and it should be from drain to source. So here drain is representing the VDD and ground is representing the source. Okay, so now onwards you shouldn't tell like this is the source and this is the great drain without knowing actual meaning of it and without knowing any applied potential. So similarly if I make my nmos like this and suppose here I am applying VDD at this terminal and here I am applying my ground. So gate, no doubtly you can make the gate, okay, or you can say like this terminal is the gate, but for drain and source you have to keep these points in the mind, like direction of the current would be what, from VDD to ground, and in nmos direction of current is basically from drain to source. So this terminal would be my drain and this terminal would be my source. Okay, now you can answer like which terminal is drain, which terminal is source. I hope I'm clear to you. Similarly, if I talk about my pmos, let's take the figure as it is, and suppose I applied a VDD over here and a source over here. So what will be the direction of current? Direction of the current will be same, like from VDD to source, but we should know which is drain and which is source. So again we have to go in the construction part. Okay, again we have to go into the construction part, just like the CMOS part, NMOS part, and we should analyze how it is basically happening. So for PMOS, we know that what would be my substrate and what would be my drain, sorry, n well or p well. So this would be my n type and this would be my p plus. Here plus nothing means it means like it is heavily doped. Okay, it is heavily doped. So again this is not our topic to discuss like what is actually happening, that I will make in some other video, but we should know like which is drain and which is source. So at least this much of idea you should be having. So as I told you, source is, what is source? Source contain majority charge carriers. Source contain majority charge carriers. And here in P plus, which are the, in P plus we know like holes are majority charge carriers. Holes are majority charge carriers. So holes are the majority charge carriers. So direction of the hole would be direction of hole will be from source to drain. And if whole direction is hole's direction is in source to drain, then current direction would be also in the same direction, because holes are considered to be the positive in nature. Okay, they're positive in nature, so current direction would be from source to drain. So we concluded that our current will be flowing from source to drain, and here my current is flowing from VDD to source, VDD to here I should write ground, I'm sorry for that. Here I have should write ground. Okay, so we considered we arrived at a conclusion that our current should move from source to drain. Okay, and here our current is moving from VDD to ground, so this terminal is representing what? Source. And basically this terminal is representing my drain. So we should always remember, like, okay, so now you can make a comparison. Okay, you can make a comparison, and you can see basically what is actually happening. Okay, where are the differences, and where we should keep these points in mind. So basically this will help you a lot to solve n number of questions, or to make your concepts clear, because if we do not know how to uh, know what is actually source, what is actually drain, then we would not be able to proceed further, or our base would not be strong. Okay, so this could be one of the good interview question also to discuss upon, and it's quite basic, but we should always prepare. Okay, I hope you have enjoyed this, you have learned from this content. Thank you very much. Thank you.